Hi guys, today we're going to dig into the features of a parabola. A few reminders and announcements. Don't forget that if you have questions, you're going to email me at bmcneely@riversidehighschool.org. It's definitely not too late to turn in late work for quarter 3 or quarter 4, so make sure you're working on anything before e-learning started or anything during e-learning. The e-learning is probably easier to do right now while you're at home because there's video lessons to go along with that and everything's online. So let's try to get the e-learning done first before we worry about going back to quarter 3. Make sure you have out a pencil and paper and be ready to take notes and try the U-Try problem as we go. Be sure you're using your school email address. If you don't know how to log into your school email address, email me and I can help you get it figured out. From this point forward, the Google Forms IP will be locked unless you are logged in with your school email. There is never a reason to guess, leave blanks, or write IDK in an answer blank. Email me or attend office hours to get your questions answered. Don't forget that quarter 4 ends May 21st. If you are passing with a C or better by then and you're happy with your grade, you are done. If not, you will need to continue working for 2 more weeks, so let's get these assignments handed in. Don't forget if you have a 60% or better, you'll be eligible for remediation at the end of the semester, and most of you can hit that mark just by handing in missing work. Bonus Point Project. We'll be offering you a bonus point project for the month of May. The project will be worth 20 bonus points and will involve you choosing from a list of specific skills and creating a presentation of your choice on that skill. 20 points is equivalent to 2 missing e-learning assignments, so it could have a big impact on your grade. We have designed this project to be possible for every student to do, and should be a boost to your grade if you make an effort to meet the requirements, even if you get a few problems wrong. The projects will be due by midnight on Friday, May 22nd. Expectations and rubric for the project can be found on today's Haiku page. Our email etiquette for today, things we've covered so far. You should be using your Riverside email. Your teachers have personal emails as well, but we use our professional emails for school business, as should you. The subject of an email should be a few words at most. The body of the email is for your message in complete sentences. All emails should include a polite greeting and closing, hello, goodbye, good to talk to you, hope to see you soon, those kinds of things. Requests should never include the saying ASAP, it's impolite. It's not too late to send me an email for bonus points that includes all of the above, or copy me on an email to one of your teachers. Here's an example of a solid email to Ms. Dorsey. So I have, first of all, I'm using my Riverside High School email address, obviously. My subject is TikTok video for Rally Dance Marathon. Your teachers get hundreds of emails every day, so it's easier for us to answer your questions if we can see the subject right here instead of a whole paragraph. I start off with a polite greeting, and I end with a closing. Thank you for considering and hope you are well. I give her a short information about what I need in complete sentences. I don't say ASAP. I don't demand that she do it. I ask her if she would be willing, she could do this, and I thank her for considering it. Let me know if you have any more questions about email etiquette. Looking forward to seeing some of your emails. Struggles or celebrations today. A few weeks ago, my brother and his wife had a new baby boy. They have one son already, my nephew Gunnar, and now the new baby, he's named Mac. I'm really looking forward to the time when I can visit them. I miss seeing them during this time. They live in Iowa, which is pretty far away. All right, today we're going to talk about what does a parabola look like. So examples of parabolas are the McDonald's arches, the Gateway Arch in St. Louis, pieces of a roller coaster could be a parabola, the aqueducts are a parabola, and the arc that a football makes when you throw it could be a parabola. We want to make sure we're able to recognize an equation that graphs a parabola. The graph of any quadratic equation that is in standard form will graph a parabola. I'd like you to pause the video. Which of the below equations are in standard form? If you don't know, stop here, go back to Haiku, and re-watch the videos on solving by factoring and solving by quadratic formula from April 15th and 16th and April 22nd and 23rd. So from here, go ahead and pause the video, and I want you to circle or write down the letters that you think are in standard form. Welcome back. Only B was in standard form on this one. Remember, standard form of an equation looks like this. ax squared plus bx plus c is equal to 0. So you've got some number with an x squared plus or minus some number with an x plus or minus some constant, and that's equal to 0 always. So A, C, and D were not in standard form. That doesn't mean we can't get them in standard form. It doesn't mean they won't graph a parabola. I want you to pause the video and try putting these into standard form now. If you don't know how, then you'd stop here. Again, you need to go back and you need to rewatch some of the older lessons. Go ahead and put these in standard form now. Welcome back. You should have noticed that A has the pieces it needs. It has a number with an x squared, a number with an x equal to a number by itself, or excuse me, minus a number by itself, but it is not equal to 0. So to fix this, we need to subtract 9 from each side because 9 minus 9 will give us 0. Remember, we can only add and subtract things that are like terms. The 9 does not have an x or an x squared, so I'm just going to bring those down. But negative 3 minus 9 is not negative 6, it's negative 12. Now that's in standard form. For this one, it's already equal to 0, but we're missing a term. We need 3 terms. We have the ax squared, we have the c, we have it equal to 0. What we're missing is a 0x here. Anytime we're missing something, the number to replace something that I don't have is 0. For this one, I need to move the negative 5x to the other side, so I'm going to add 5x to each side to create a 0. And remember, you cannot add and subtract things that are not like terms. So all of these just go next to each other in standard form, and we make that equal to 0. All right, we're going to first start by talking about direction of a parabola. A parabola can either open up like a cup, the one on the left, or down like a frown, the one on the right. The little rhymes will help you remember what they do. If I ask you what direction, you don't have to say up like a cup, you can just say up, but I certainly won't count it wrong if you say up like a cup. The vertex of the parabola. The vertex is either a maximum or a minimum point. If the parabola opens up like a cup, like this one, then the vertex is our minimum point because it is the lowest point on the parabola. The parabola stops here and starts going back up in the other direction. If the parabola opens down like a frown, like this one, then the vertex is the maximum point. It's the maximum point because it is the highest point on the parabola. If the curve's going up this way, it's going to go back down once it hits the vertex. I want you to pause the video and try to answer this question. Does this parabola have a maximum or a minimum point at the vertex? Welcome back. You should have said that this has a minimum point here. It has a minimum point because the parabola opens up, so the vertex is the lowest point there. All right, pause the video again. Try to answer this question. Does the parabola have a maximum or a minimum point? You should have said that it has a maximum point because the parabola opens down, so the vertex is the highest point. It's important to note that the parabola continues on either to positive infinity or negative infinity as we move away from the vertex. So on this one, our vertex was the minimum, and from then on, it goes up to infinity. It's never going to stop going up. This one goes down to infinity. It's never going to stop going down. Just because we run out of space on the graph or on our screen doesn't mean that the graph stops. We just run out of room with how we can represent it. That's why we put the arrows on the end. One property that a parabola has is that it's symmetrical along a vertical axis. If we folded a parabola in half vertically, then the two sides would be exactly the same. I want you to pause the video now and try to determine which of the below shapes are symmetrical along a vertical axis. All right, so what I've done is draw a line through the middle of each one of these shapes. The yellow, green, and purple shapes are symmetrical along their vertical axis. If we were to fold those in half along those lines, they would be perfectly symmetrical. The red and the blue are not. If we folded them in half, the sides would not match. All right, the axis of symmetry, that fold along which we were talking about folding those shapes, it's a vertical line that cuts the parabola in half. Our vertex point always is going to fall on that axis of symmetry on a parabola. It's always going to be somewhere on that red line. The code word for today. The code word for today is going to be Mac, because my brother has a new baby and his name is Mac. So make sure you write that in your notes now so that when you get to the thing, you don't have to say, I don't know. The axis of symmetry of a parabola is a vertical line that cuts the parabola in half. We said the vertex always falls on that axis of symmetry. Vertical lines are always written using the form x is equal to some constant. We can easily use that to find the equation for the axis of symmetry by looking at the graph. Since the vertex falls on the axis of symmetry, the vertex will be a point where x is the axis of symmetry. So let's do some review. First of all, this parabola opens up like a cup, which means that its vertex is a minimum. But I can be more specific about some of the information on this graph. Its axis of symmetry cuts right through here. It cuts right through the vertex, and it cuts right through where x is 1. So its axis of symmetry is the line where x equals 1, which means its vertex is the point 1 comma something, because it has to be on that x value of 1. Well, we can see that it goes down to -4, so it's 1 comma -4. I want you to pause the video now and answer the following questions. Welcome back. You should have said this is a parabola that opens up like a cup. Its vertex is a minimum point. Its axis of symmetry is the line x equals 3, cuts right through here. And its vertex cuts through, or excuse me, is right on that line. So it is 3 comma, and we can see that we need to go up to 1. So it's 3 comma 1. I want you to pause the video now and try to answer these questions. Welcome back. You should have said that this parabola opens down, and which means that its vertex is a maximum. Its line of symmetry cuts right through the middle. Hopefully you can make a straighter line than I can. Its axis of symmetry is the line where x is equal to -1 because it cuts through -1 on the x-axis, which means that our vertex is the point -1 comma 4. All right, pause the video again. Try to answer these questions. You should have said this parabola opens up, which means that its vertex is a minimum. Its axis of symmetry, it cuts through 0, so it's the line x equals 0. But here the y value is also going to be 0. Its vertex falls right on the origin. Its vertex falls right on 0, 0. All right, zeros of a parabola. The zeros of a parabola are the points where the parabola crosses the x-axis. You've already worked on these. You already know how to find these with the equation. They are what we find when we solve by factoring or solve using the quadratic formula. For this curve, there are 2 zeros because the blue line crosses the x-axis twice. The zeros are -3 comma 0 and 1 comma 0. You could also say that x equals -3 and x equals 1, which is what we get when we solve those equations. You don't have to write it as a point as long as you recognize that those are falling on the x-axis. For this one, there is only 1 0 for this parabola because the red line crosses the x-axis once. The 0 is, you can either write it as x equal to 0 or the point 0 comma 0. If there's only 1 0, then the 0 will always be the same as the vertex. If there's just one of them, it has to be the same as the vertex. It can't be anything else. It is possible that there could be no zeros. Here we have a beautiful curve. It's up like a cup. It has a minimum. It has a vertex at 3 comma 1. But there are no zeros for this parabola because the curve does not cross the x-axis at all. This is what happens when you cannot solve an equation by factoring or by using the quadratic formula. When you were writing no solution on your homework, when I asked you to find the zeros, this is what was happening. It was not touching the x-axis anywhere. Next time, we're going to learn more about zeros and using them to graph. I want you to pause the video now, and for each of these graphs, identify the zeros. Welcome back. For this one, you should have said the 0, there was only 1, is at x equals 3. For this one, you should have said that the zeros were -3 and x equals 1. And for this one, you should have said there were no zeros. The parabola had 1 0 at the point 3 comma 0. The parabola had 2 zeros, one at the point -3 comma 0 and the other at the point 1 comma 0. And this one has no zeros because the curve does not cross the x-axis. Good job today. You're going to return to the haiku page and complete the assignment on features of a parabola for 5/6 and 5/7. Don't forget to take a look at the rubric and expectations for the project to help boost your grade. Hope to see you soon in office hours. Miss all of you. Bye-bye.